All right. Okay, so welcome to our IoT authentication proposal. Quick note before we start, I can't get my camera working, so I'm sorry about that. But let's keep going. So my name is John Morin. I specialize in hardware security with the ECE department.
Yep, my name's Keith. I'll be doing the OS scripting, and I specialize in the ECE department as well.
And I'm Bojan Nandesh. I'm a mechanical engineering student.
Hi, I'm Venkat. My specialization is real estate technology in PC department.
All right. So our core project is going to be centered around bank security. So what we're planning on doing is developing a double-keyed wireless security system. So this will be set up in 2 stages. And so in the first security level stage, we will have 2 people who are 10 feet apart, and they both have to authenticate using an NFC system that they are who they say they are within a couple seconds of each other, so that it verifies that there are at least 2 people present during this access point. Once that happens, the keypad becomes available, and that would require that one of the people knows the logic behind it or knows the passcode in order to be able to access the vault. And so once the keypad is then accessed and validated, then the vault door will open.
Now we are going to talk about the citations. The first citations is about machine-to-machine communication-based smart home security systems. So it's all about developing a multi-layer home security system which has levels of security, in which the first security level uses NFC tag, and the second level uses a secured passcode, and the third level is fingerprint sensor. If the unauthorized person wants to enter by breaking, the sensors will work and sounds a buzzer for alarm. And the second citation is about the NFC model for Arduino Uno based security systems. This gives all brief explanations about all the definitions of Arduino's sensors, and these 2 citations will help us to move further in the IoT project. And if you look at this block diagram, this diagram gives the overall picture of security functionality.
So purpose and requirements. Our purpose for this project is to authenticate that 2 or more people who are approved by the system are present when accessing the vault. This is done through the NFC chips that we'll have with the NFC sensors in parallel. And the security requirement is that the NFC and the keypad will provide ample security, and the cloud provides API security. So both users will have NFC chips. They both hit their sensors at the same time. Then this will provide access to the keypad. The keypad then can be entered in with the correct combination, and then a lighter door or some kind of actuator will occur. Here's our process specification. So this is just a more in-depth model of that. So we're going to have 2 NFC sensors. This will be connected to 2 separate Arduinos. So this will have one separate Arduino connected to an NFC, the other Arduino connected to another NFC, and they're going to be communicating via the Wi-Fi modules we have to our cloud system. And then we have our master Arduino that also has the keypad and reward gate door system also attached to it. So when the NFC receives the correct key, that key will then go up to the cloud. It basically says yes or no. Is this access? Is this not access? If both of them are accessed at the same time, it'll take back down from the cloud periodically every couple milliseconds. And then it'll grant access to the keypad. And then if the keypad combination is correct, then ideally it'll send a log back up to the cloud that we can record that data. Here's our functional view. So physical components include the guards with the NFC chips. These are going to be on top of the Arduino and associated with them, and the vault door itself. We have our virtual components, which is the code to control the chips, the Arduinos, the keypad code as well, and the lock door. In devices, we have 3 Arduinos. We have the Wi-Fi chips to communicate between them. We have the 2 NFC sensors, 1 keypad, 1 RGB LED, and a linear actuator for the door. Communication requires a link layer, IPv4, IPv6 network layer, the TCP transport layer, HTTP for Wi-Fi communications is going to the cloud, and this is transferring to a MongoDB service or server. This is going to also use the Wi-Fi NINA API functionality, and the controller service is going to be hosted on our master device, implemented with C++ code in the Arduino IDE that we'll be using to program. Management. The management of the system comes from the Arduinos. This will have our main system controllers. And security is already described, but to go over again, the NFC chips, the users will have NFC, so if they are not authorized, then they're not authorized and it will not gain access to the system. Required again, both users need to have access in order to get access to the keypad. And then the physical authentication itself is the keypad itself.
Yeah, so how we're practically going to approach this, we've split the design because we have 4 people. Our situation is a little bit more unique than most groups. So what we're planning on doing is, because there's a very clear divide in work between the actual keypad and NFC sensing, we found that that was the most natural place to put 2 different people on that design. So 2 people are going to be working on the sensors hardware design. And so Venkata and Bogachan will be working together to actuate and interface these all three sensors with the Arduino code. And on top of that, any sort of miscellaneous work that we'll have to do in addition, such as, the vault door, actuating the vault door opening, or so on, or any sort of LED indication, any sort of display that you would need to help the user interface. They will be responsible for that. Venkata will initially mainly work on the keypad portion, so being able to actuate the keypad, as well as working on actuating the vault to make sure that it indicates when it's ready to go. And then Han will focus mainly on verifying that the 2 NFC chips will be on at the same time and interface that communication to the wireless user. And so I will be working mainly on the communication with that information, and then be sending that to, using the Nina library, sending that to Keith on the cloud. And I will also be working any sort of logical functions that are very time critical, that could be delayed from sending to the cloud. We will be doing on the Arduinos currently. And then Keith will be responsible for any sort of interface from the cloud side of things. And he will be using MongoDB for that information. And he will also be responsible for any of because the cloud has much higher processing power than the Arduinos, he'll be responsible for handling any of the more complicated or intensive logical functions.
All right. So in order to accomplish this project, we have set up milestones. And as you can see on the screen, there's also a Gantt chart to describe our milestones. So first of all, for the project, we are still trying to gather our hardware together. Currently, everybody is looking at their places to find some spare Arduinos, wires, or some other sensors, or some potential actuators that can replace the vault door mechanism as of week 5. So following week 6, we are hoping to start to see some interactions between the wireless communications, and hopefully we'll start the Keith will take the lead on the database initialization. So for week 6 and week 7, we are planning to put things together. And starting from week 9, we are hoping to find the incompatibilities between the systems, sensors, or the hardware in general. And then from there, we will start the initial testing on the capabilities of the sensors and their interactions with Arduinos. The most important thing, in my opinion, because I'll be taking over the NFCs. I would like to see the sensors capability in terms of the radius around the NFC. And if we go to the next slide, to the wireless milestones, as I spoke earlier, the NFC modules and their communications will be very essential for the project. We gotta make sure they don't interfere and they also work at the same time. So we will be heavily focused on the testing of that portion. As far as the communications, there are mainly 2 links happening for the project: the Wi-Fi communications and the Arduino's communications through cloud. So at the first layer, the Wi-Fi communications, John will take the lead on the development of the software, since he's more capable of operating systems, coding, and RTOS. And yeah, so the other link, the in between Arduinos and the cloud, Keith will take the lead, and hopefully by the end of week 11 or the start of week 12, we're hoping to merge everything together from every hardware component and also the software components. Next slide, please. So for cloud, as we can see on the lower Gantt chart, the initialization will start on the week 6. And as part of the testing, we will start to see around week 8 that we can receive and send and receive data from the cloud/database. And as I mentioned earlier, we want everything to be in harmony so that everything will work out fine. So during week 12 and from there on, we're hoping to merge everything and then finish the project, hopefully. Well, thank you guys so much, and would like to extend my thanks to my teammates.
Hoorah.